All right, this is our third video in this section. So let's keep going with these limits at infinity just to see how they go. Okay, so for e, it's going off to infinity, and it's a tie again. The degrees are equal, so the leading coefficient on top is a -8. Leading coefficient underneath is a 3, so it's just a -8/3. So if the leading coefficient is already a negative, just take the sign with it. And same thing over here. So again, it doesn't matter if it's either infinity or negative infinity when the degrees are equal, because it's going to work out to be the same thing. So just to verify it, I'll show you why. So you're plugging in negative numbers. So a negative number times a -8 is a positive. But then underneath, you have a +3 times a negative, which makes it a negative. So you still end up with -8/3. Now, sometimes it does matter what you're approaching with functions like these. So it doesn't look like you've got something that has a degree, and you really don't. But again, we're only paying attention to the highest powers of x. Everything else doesn't really matter. The highest powers are always the boss. They tell everybody else what to do. So on top, you can ignore the 1 in the root. You just want to pay attention to the x squared, which means you just really have root x squared, which ends up being just x. And so now the degrees are equal. So your ratio of leading coefficients is just 1/1, or 1. Now over here on h, it's the same exact function. So the top just simplifies to x again, and it's still a tie, but now that negative infinity is really going to come into play. So it makes the denominator a -1, but the top, it's going to stay as a positive, because if you square root anything, you always get a positive result. So 1/-1 gives you a negative. So if your functions have radicals involved, you really now do have to pay attention to the signs, because it can affect it. And as well as like these down here, that's going to affect it as well. Because these are ones where you can't really look at the degrees anymore because there isn't a degree. So for example A, you just kind of have to think about it. You're going to plug in like a really, really big number into that exponent. It's like e to the infinity. It's not really what it is, but you can kind of think of it in that way. So e to the infinity, that should be super huge, right? It's going to be basically infinity. Well, infinity times 7 and then added 6 is still going to be infinity. So now let's look at this one. Now you're plugging in a negative infinity. Well, what does a negative exponent do? It flips it. So 7/e to the infinity. Well, if the denominator is getting super huge, like 7/10 million or 7/100 billion, that's making the fraction go off to 0. So you have 6 plus 0, which is equal to 6. All right, for c, you have 10/5 plus 2 to the infinity. So 2 to the infinity, again, is going to be it's really big. So your denominator is getting super huge again. So it's pulling the whole fraction down to 0. But when we have the same function, but now we change it to negative infinity, now it's really something like that. So the negative exponent, flips it upside down. so on the 1 over the 2 to the infinity, this fraction, that little fraction goes off to 0, which makes the overall fraction 10 over 5 plus 0, or 10 over 5, which is really just 2. All right, the last two, with the trig function, as x goes up to infinity, the denominator is going to get really, really, really big. But cosine is always trapped in between 1 and -1. So your numerator is just bouncing between -1 and 1. So it's not really getting very high, but the denominator is, so the denominator is forcing the fraction down to 0. And then this last one, as x goes out to -infinity, that'll force the 1 over x. That makes the fraction go to 0, and then cosine of 0 is going to equal 1. Okay, so just, you kind of have to use a little bit of logic and common sense with these. If you don't like plugging in the infinity, if you're just like, that's just too weird, you can always plug in a big number, like 1,000, and just kind of think about it. It's like, if I plug in 1,000, is that going to make it big, or is that getting it close to 0, or what is it doing? All right, so go ahead and try the homework out for these and let me know if you have any questions.